measurement. Lesson 4 is conversion in the SI system, Scientific International, which means that everything moves with powers of 10. So this is the metric system. There are 3 methods to doing this. We can use the SI chart, we can use proportional reasoning, and my favorite is the unit analysis down here. So you're expected to be able to do unit conversions. The first method, we can look at a chart and figure out how we would get to meters from, say, a gigameter. So a gigameter is over here, and a meter is over here. So this is the unit. It might be meters, it might be grams, it might be liters. Don't get this confused with the milli. This M stands for milli, it doesn't stand for meter. So from this chart, you can see that a giga is 10 to the 9. So it's actually a very, very large number. And there would be 9 zeros behind it here if I wanted to convert back to meters. Whereas over here, if I had something very small, this is to the -6, you're going to end up with a very small number of meters. Now, how come there are only 5 zeros when I'm expecting it to be 6? Well, 6 represents the number of spaces moved by the decimal point. So if you move this decimal point by 6, 1, 2, 3, 4, 5, 6, then the first step was across the 1, so you're only adding 5 zeros and then the 1 at the beginning. So 0.000001. And that's 5 extra zeros, but only 6 decimal steps to get that decimal place over here. So the best way to think about it is in terms of decimal steps. So 1 milligram, how many grams is that? Well, it'll be 10 to the -3. So if we move this 1, 2, 3 steps, the decimal place now lives here. So we have 0.001 grams. In class example number 1, they're asking us to use a number line, metric unit number line, to complete the following. So this is a number line that actually shows all the different steps by powers of 10 to get from the unit to giga and the unit to nano. And they haven't skipped any steps, so this is actually 9 steps away from the unit to get to nanometers. So the unit could be meters, could be grams, could be liters, could be something else. If we are going from 1 meter, which is here, and we're trying to get to centimeters, we're going here. So that's 2 steps to the right. So we are going to move our decimal place 2 steps to the right, and we'll end up with 100 centimeters. If you want to go from 1 millimeter to a meter, that means we are standing here, and we're trying to get back to meters. So 1, 2, 3 steps to the left. So we are going to move this decimal place 3 steps to the left. 1, 2, 3. So now it lives here, and we just have to put zeros in on top. So it'll be 0.001. From liters to milliliters, so we're here at our main unit, and we're trying to get here. So 1, 2, 3 steps to the right, and that's what our decimal place is going to do. So 1,000 milliliters. What if the number is not 1? What if we're asked to convert 7.5 to centimeters, meters? So let's just erase our old work here. And we're starting with 7.5 meters. So we're starting here. And we're going to centimeters, which is here. So 2 steps to the right. So the decimal place is going to move 2 steps to the right. So we're going to have 750 centimeters. If we're going from milligrams to kilograms, let's see. So milligrams is here and kilograms is here. 1, 2, 3, 4, 5, 6 steps to the left. So we're going to move our decimal place 6 steps to the left. 1, 2, 3, 4, 5, 6. So if we do that, we're going to have to add a 0 at the beginning. And that'll be kilograms. 325 micrometers to nanometers. So let's look at that. So we're starting with the micrometers, which is here. We're going to the nanometers here. 1, 2, 3 steps to the right. So we will move our decimal place 3 steps to the right. 1, 2, 3, and we're going to have to add 3 zeros at the end of it. The last one says convert in scientific notation. We're not doing scientific notation in this particular class, but it is a very useful skill to have for science.